Okay, so we are going to take a look at limits from a little bit different kind of view here. So let me go to our notes, and here's the last thing we were talking about. We were doing the limits with E. So this is the stuff we just went over on the class kick. And when we were doing that, most of our limits were to either positive infinity or negative infinity, going way to the right or way to the left of the graph. So this is going to be a little bit different what we do here today. So we're going to do limits to a number. Now, there's good news and there's bad news when we talk about taking limits to a number. So the good news is some of them are super easy. The bad news is that they're all a little bit different. And sometimes it can be a little bit hard to categorize what kind of problem you're doing. But once you get it into a certain category, the method from there is pretty easy. It usually is just, can you figure out what type of problem it is? So for example, let's say we wanted to start our first example. We want to find the limit as x goes to 4 of x minus 2. So what I'm saying, the difference is, this, we're going to now a number 4, we're not going to infinity or negative infinity. This is an easy one. When you're trying to find the limit to a number, the first thing you should always do, just try and plug the number in. Sometimes that works. In this case, it does. All I'm going to do is take 4 and plug it in. 4 minus 2 is 2. That's our answer. Okay. Just plug it right in. Now, sometimes when you plug it in, though, you get weird things that happen, and that's where we're headed. Okay, but always try and plug it in first. But let me give you a similar example. So let's say we want to find the limit as x goes to 4 of x squared minus 6x plus 8 over x minus 2. Oh, I'm sorry. I'm going to change this slightly. I'm not going to go x minus 2. The bottom is going to be x minus 4. Because that causes a problem. And the reason that causes a problem is because I can't do that direct input here. Because if I put 4 into the function, the top is fine. I could do 4 squared minus 6 times 4 plus 8. Problem is 4 minus 4 is 0. I can't have 0 in the denominator. Now, that doesn't mean the limit doesn't exist, though. What that means is we need to try a different method. So the first thing is recognize that we can't just directly plug it in. Then we're going to try a different method. But the good news is that method is not so bad. One method is just try and factor the top and bottom and see if we can cancel out the denominator. So for example, in this case, the top factors into x minus 4 times x minus 2. And the bottom was x minus 4. And so now notice that the x minus 4's cancel, right? And now that the x minus 4 is canceled, now plugging it in is no longer a problem. I can take 4, just plug it into what remains, and 4 minus 2 is 2. So the only difference between the first one and the second one is in the second one we had to factor it. All right, any questions yet? Because now you're going to have to think a little bit, just so I can explain it. The algebra of it is pretty straightforward. Here's what's happening, okay? Think about the graph of x minus 2. That's just a line with a slope of 1 and a y-intercept of negative 2. Okay, it just, oops, that was ugly. Not what I want. It just looks like that. Okay, that's the line of x minus 2. So what this question is asking, it's saying, when your X value is 4, okay, what does the Y value approach? And so if you go, 1, 2, 3, 4, we're just talking about this point in the graph right here and thinking of limits, graphically, as we approach from this side and we approach from this side, they go to the same thing. And that's why the limit is equal to 2. The only difference between that problem and the one below it is, remember when we did rational functions? And when a factor canceled out, we talked about the fact that that makes a hole in the graph. So the graph is the same. It's still this line here. But it has a hole there. But the limit stays the same, because remember, graphically for the limit, as long as we're coming from the left and from the right towards the same point, okay, we're coming both towards the same point here, then the limit is going to be at that point. And so that's why it's still going to 2 coming from the bottom and coming from the left, I should say, and going to 2 coming from the right. All right, so that was just a little graphical explanation of it, but let me, do some more algebraic ones here. All right, so let's find the limit as x goes to 1 of x squared minus 8x plus 7 over x minus 1. All right, so the first thing you want to do is in your head think, all right, are we going to infinity? No, we're not, because we're going to a number. So I'm not doing the positive negative thing. Can I do a direct substitution? Well, unfortunately, we can't do a direct substitution. So then our next and final method that we've done so far is try and factor the top and see if the denominator cancels. So in this case, the top factors into x minus 7 times x minus 1. And our denominator was x minus 1. So they do cancel. And then we just do a direct substitution. So now I'm just plugging the 1 in for x, and 1 minus 7 is negative 6. All right, let's do another one. You guys good? Am I going too fast? You guys okay? Okay. And you guys at home too, please make sure you just speak up if you have questions. All right, let's do the limit as x goes to 2 of the same function. The limit as x goes to 2 of x squared minus 8x plus 7 all over x minus 1. So first thing, check and see, is it to infinity or negative infinity? It's not. Okay, so we're not doing the positive negative thing. Next check is, can we do a direct substitution? It looks like we can in this case. So all I'm doing is taking 2 and plugging it in for all of the x's. So on top I have 2 squared, so that's going to be 4 minus 8 times 2 is 16 plus 7. And on the bottom, I have 2 minus 1. We just add them up. So I had, what is that? Negative 5 over 2 minus 1 is still negative 5. All right, I'm going to just keep rolling and throwing a couple more at you guys. Let's stick with the same function. Let's find the limit as x goes to infinity of x squared minus 8x plus 7 all over x minus 1. And so for that one, this is going to infinity. So now it's a rational. We do the top heavy, bottom heavy or equal thing. Well, looking at this, it's top heavy. So if it's top heavy, now I got to figure out if the top and bottom are positive or negative. So if I plug positive 1 billion in for x, and I'm only concerned about the x squared because the highest exponent. So a positive billion squared will be positive. And on the bottom, a billion minus 1, of course, is positive. And a positive divided by positive is positive infinity. All right, so now we're going to do the same function, but now finding the limit as x goes to negative infinity. So we're finding the limit as x goes to negative infinity of the same function. So I'm going to take negative 1 billion squared. So that's going to be positive because a negative times a negative. And then I do negative 1 billion minus 1 will be negative. And a positive divided by negative is going to be negative. So that's going to go to negative infinity. All right, so now I'm gonna write 3 of them up there. I want you guys to just give them a shot, okay? And I'm just gonna give you, maybe 2 minutes, and then we'll go through these 3 together here, okay? All right, the first one, let's find the limit as x goes to negative 3 of x squared minus 2x plus 1 over x minus 1. That's our first one. Then we're going to find the limit as x goes to negative 3 of a different function. Now I'm going to change it. X squared plus 4x plus 3 over x plus 3. And the last one, we're going to find the limit as x goes to negative 4. And again, I'm changing the function. So x squared plus 2x minus 8 over x plus 4. All right, so you guys take a couple of minutes, work on those, and we'll go over those together in just a couple of minutes. All right, let's take a peek at the first one. So it is, we're going to a number here, right? We're not going to infinity. So when we're going to a number, then the first step is, let's see if we can just do a direct substitution. In this case, we can. So we're just plugging negative 3 in for x. So on top, I'm going to get negative 3 squared will be 9. And negative 2 times negative 3 will be plus 6 plus 1. My denominator is negative 3 minus 1 is negative 4. And so what do we get? 16 over negative 4, which is negative 4. Okay. So we just did a direct substitution. That's always the easiest way. So we always want to try that first. The problem for the second one is we can't do a direct substitution because we get 0 in the denominator. So unfortunately, we can't do that. But what we can do then is try and factor. And in this case, the top factors into x plus 3 times x plus 1. and the bottom factors into x plus 3. So we now have canceled out that problematic factor on the bottom, right? We're left with just x plus 1. And now we can do a direct substitution. So I'm plugging -3 in for x, and -3 plus 1 is -2. All right, the last one is similar. We can't do a direct substitution, unfortunately. So I will then try and factor. And so the top is going to factor into x minus 4 times x plus 2. Yeah, please make sure I don't screw up my factoring there. I've been known to do that. And I just did, actually, as I was speaking. This is x plus 4 and x minus 2, sorry. Right, yes, x plus 4 and x minus 2. Sorry about that. And you know what a good hint is? The reason we're trying to factor is to cancel out the bottom, right? So, always try that as one of the factors. And it does cancel out. So I have just x minus 2 left over. I'm going to take that and now do direct substitution. And -4 minus 2 is -6. All right, you guys have any questions on any of those? Is it okay? Or at least understand it a little bit? Okay, so we're on to the class kick, and I'm just going to do this column on the left here. So we're going to find the limit as x goes to 2 of f of x. This looks like just a direct substitution question. So I love when that happens. All I'm going to do is plug the 2 in for x's. So 2 squared is going to be 4, plus 6 times 2 is 12, of course, minus 16. And is that 0, right? All right, we okay with that one? Just a direct substitution for the first one. Now for the second one, I usually like to rewrite these. Okay, you don't have to, but we're finding the limit as x goes to -8 of f of x, which is x squared plus 6x minus 16 over g of x, which is x plus 8. And unfortunately, I cannot do a direct substitution. So I'm going to have to factor in this case. When I factor the top, I get x plus 8 times x minus 2, which is good news because then my x plus 8s are going to cancel. And now I do my direct substitution. So -8 minus 2 is -10. So when we take a quiz for these next week, hopefully you guys are starting to get used to these. If you need me to re-explain, just slow me down or something. I'm going to do the next one. The limit as x goes to -8 of g of x. That is a direct substitution. -8 minus 8 is 0. And that's perfectly fine to have a limit of 0. Now, problem number 4 and 5, those are different. So you got to be careful because here we're going to infinity and negative infinity. So different type of problem. So I'm finding the limit as x goes to infinity of f. F was this guy. So that's a polynomial. It's quadratic, more specifically. And so all I'm trying to do is figure out if the ends are going to go up or down. If they're going to go to positive infinity or negative infinity. So if I plug 1 billion in, I'm only concerned about that term. And 1 billion squared will be a positive number. Therefore, it will go to positive infinity. Negative 1 billion squared will also go to positive infinity because negative times negative. All right, 6 and 7 also are the infinity type problems. So now we're doing the positive negative thing. I'm plugging it into G. So positive 1 billion plus 8 would go to positive infinity. And negative 1 billion plus 8 would go to negative infinity. And now the last one is talking about you know, if it's a rational function, so f, which is x squared plus 6x minus 16 over g of x, which was x minus 8. Sorry, my handwriting is bad there. X plus 8 on the bottom, sorry. And we're trying to find the limit as x goes to infinity. So now it's rational. So again, we're trying to figure out if the answer is, well, we do the top heavy, bottom heavy are equal. This is top heavy. Positive number squared is going to go to, that's going to be positive. The bottom will be positive, and a positive divided by positive will be positive infinity. Now, if I plug in negative 1 billion, well, negative 1 billion squared, a negative times negative still will be positive on top, but on the bottom, negative a billion plus 8 will be negative on the bottom. So that is going to go to negative infinity. All right, so there are our solutions for that class kick. You guys have any questions on those?